Hello, Calculus, Section 8.3, Part D. We are now going to talk about the shell method for finding the volume of solids of revolution. This is the last lesson in Section 8.3, and it uses the skills we've already learned for the disk and washer method and understanding those. So make sure you understand how those rotate around and whichever axis they're rotating around, that is the variable that you're going to integrate with respect to. Now we're going to turn this on its side. So instead of integrating with respect to the same axis, we're going to integrate sideways. So for example, if I've got this triangle here, if I wanted to spin it around the x-axis, I have this horizontal piece. So as I spin it, I'm going to make a cylinder, and that cylinder is going to be like circumference, like the shell of the cylinder. And we're going to do it is going to grow smaller, and from this little tiny one that's a big circle, that circumference plus this circumference plus this circumference. So we're basically taking all of these circles and adding them up as we go. So it's not pi r squared based, it's 2 pi r, because we're looking at the circumference of the circle or cylinder and spinning that around instead of grabbing this and spinning this way. So some problems can be done either way. So like this triangle right here, if I knew the equation, I could totally use the washer method, because I could use the top piece and spin it around area minus the bottom piece spun around, and I would get the same thing. I could do it all in one step if I do it like a cylinder, a shell. This is called the shell method. So basically, you're going to have your piece that you're looking at is horizontal to the axis that you're rotating. When we do disk and washer, the piece that we're integrating, the vertical piece, would be perpendicular to the axis that you're looking at, not parallel. All right, so let's take a look. So these pictures look a lot the same. The difference is that when we're spinning around the x-axis, this is a horizontal parallel bar instead of a vertical. So for vertical, it's the disk method. For horizontal, it's shell, because you're making all these cylinder circles. You still are going to integrate. The difference is, instead of using like the pi r squared base formula, you're using 2 pi r h. So 2 pi r h is the formula for what's it called? Yeah, circumference of a circle times its height. So that'd be like the area of the outside of a cylinder. So your radius of your cylinder will be the height of the function, basically, as you go along here. And the h would be the height of your bar, which will be your variable, dx or y, dy. Let's do one that actually has numbers. So here we have the region bounded by the curve, the square root of x, the x-axis, and the line x equals 4. So I always recommend drawing a picture first so we know what we're talking about. We're going to be only in the first quadrant, so I'm going to just draw it in the first quadrant. We have the square root of x, the x-axis itself, and the line x equals 4. So at x equals 4, this would be a 2, because the square root of 4 is 2. So there's kind of my boundaries, so I know what I'm looking at. And we want to find the volume of the solid. So there are definitely two ways to do this. Let's review the disk method first. So the disk method, I'm rotating around the x-axis. So I'm going to do this little arrow here. If I want to revolve it around the x-axis, I can just use my volume formula. So that would be the disk method. So I'm going to integrate from 0 to 4 of pi. The radius of my shape would be the square root of x squared dx. And that is perfectly fine. That's all they asked for. But in order to help you understand the shell method, I'm going to do a problem that we could have done with the disk method. And then later you'll see that there are some that are definitely better set up for the shell method. So we need this. Otherwise, they get really hard. So instead of looking at all these little circles that I would make this way, I'm going to slice pieces this way and rotate them and get little cylinders. So what I need to know is how long is this thing? Each of these red bars, they're changing as we go, but they are, they start with the bigger number. So 4 minus the function. So how wide is this strip? It is 4 minus the square root of x. Nope, I forgot. We have to turn that into y. Sorry. This function right here is y equals square root of x, otherwise known as y squared equals x equals y squared. So when you want to do the shell method, when you're rotating around x, you're actually going to integrate with respect to y. So it's always the opposite of the way you're rotating. So since we're rotating around x, we're actually going to integrate with respect to y. So in terms of y, this length here is 4 minus y squared. There we go. Not the square root. 4 minus y squared. And that is this direction. And this is changing y as I go along. That's my y height. I'm taking these slivers, and the width of each sliver is the length of y. So times y, and then we have 2 pi RH. So that's my formula. Because I'm going in terms of y, this would be from 0 to 2. Now you can go ahead and calculate both of these. They clean up pretty nicely and can be done by hand, or you can type them in your calculator, but you will notice when you do them that they both equal 8 pi. So again, it doesn't really matter which way you do it. Not sure that I explained that great. If you're still confused about the shell method, you should probably watch a few other like Khan Academy videos or other things just to try to get the hang of this lesson a little bit before we finish up. So here's another example. Just turn one around a little bit. So this one, we have the equations in terms of x, and we're going to spin in terms of y. So they've already graphed this one for us. We have a parabola, a line, and the x equals 0, the y-axis. So we're spinning this shape around and making a 3D model. So we have the equations in terms of x, we're spinning around y. So we're going to integrate with respect to x. So we're going to go from 0 to this point, which we'll find that in a minute because that's not a nice answer. So I'll deal with that in a little bit. Because I am doing opposite direction, we're going to use the shell method. So I'm going to do 2 pi. The radius of this shell will always be this vertical line. That's why it's drawn here, how far apart these two are. So that's the parabola minus the line. And then that all is times how much I'm moving along there in this direction, which is x dx. So that's the setup for my problem. I did skip this step right here. So we need to figure out actually how far to go, because if we keep going, we're going to have a problem. So we need to find this point of intersection. Take a moment and find that point. You just set the two equations equal to each other. So we need to do 4 minus x squared equals x. And oftentimes the algebra is what gets you. So just be careful. I would pause the video and see if you can solve this. And then see if you get the same answer that I did. I'll go ahead and finish. So I'm going to add the x squared over here. Solve this. This is not factorable, so we have to use the quadratic formula. Plus or minus, -1 plus or minus the square root of b squared minus 4ac is 1 minus plus 16 is 17 all over 2a. That's not nice. Only one of them comes out to a nice answer, and it is 1.562. That's the positive answer that would make sense for this one. There's another answer over here, but we don't care about that one. 1.562. So that's where I'm going to integrate. And then we put that in the calculator. Pause the video, and check your answer. So the volume of the solid is 13.327 units cubed if there were any units on there. I felt like I didn't have enough examples, so we're going to have a couple more here in a minute. But this just kind of goes back over for the disk method. If you have a sliver that's easy to find with horizontally, and you're spinning around the y, that's in terms of y, and that's around the y, you're going to use the disk method. This is in terms of x, and spinning around the x, you're going to use the disk method. Down here, this is in terms of x, but I want to spin it around y, so I'm going to use a shell. So just remember, with the disk method, you're doing pi r squared as your base, and with the shell, you're using 2 pi r h as your base. So you're going to integrate the part with variable. All right, another example. Find the volume of the solid formed by revolving the region bounded by the sine of x and the x-axis, so this piece we have here, from 0 to pi, but we're going to spin it around the y-axis. So if I spin it around this way, I would get like, I don't know, the diamond-ish shape. But if I spin it around this way, I get like this jello mold. That looks like a jello mold to me. So we're going to do all these little circles, are going to make all these little cylinders, and we're going to do the shell method. So to set up the shell method, we're going to integrate in terms of x, but we're spinning around y. So we're doing shell. So it's 2 pi. For the x, we're going from 0 to pi. And my height, that's just sine of x. And my width is x. The x is what I'm taking those little steps, dx. And I believe that's it. We just have to find the integral there and get an answer. So below there, I've got the answer that I found. Just to kind of, they did it by hand. There is a way to do this without your calculator. You have to use integration by parts. So I thought I'd leave that here so you could see it, but you can see the answer down here at the bottom is 19.74 units cubed, because we are talking about volume. All right, here's another one. Find the volume of the solid by rotating the region. Y equals 0, y equals this graph, x equals 0, and x equals 1. So cutting it off to the piece we see, we're rotating around the y-axis. So sometimes drawing that helps. We have a nice easy height to find with respect to x. If I tried to do it this way, I could probably do it. I would have to do a piece here where I have a rectangle, and then a piece here. As long as this is flat, it would work. So I'd have to do it in 2 pieces and could rotate it in respect to y. But we can also do the shell method. So for the shell method, we're going to have 2 pi. I'm rotating around y, so I'm going to integrate with respect to x. And the width is always x, because that's what this is getting bigger and bigger and bigger and bigger and bigger by x. The height of it is simply this function right here, 1 over 1 plus x squared times x dx. How far am I integrating? From 0 to 1. And that's the setup. So you just have to remember that it's the opposite of the way that you're spinning, and try to get those set up. And then you can type that in and check your answer if you'd like. The answer is also here on the next page. That's the setup, and that is the answer. So you're welcome to pause the video if you want to see how they integrated that by hand. They used substitution on this one. So they're going back and practicing those integration skills. I'm just trying to show you the setup for the shell method. I have another little challenge here. I want to see if you can find a way to set up how you would solve each of these different rotations. So we have the same graph. Here, I'll draw a little picture of our graph. So we have that. We have the graph of 2x squared. So 0, 0, 1 goes through 2, and then 2 squared is 4, 8. Oh no, I pushed a button on my calculator, or computer just a minute. So 1, 2 is at 8. This is 2, and this is 8, just so we have reference. And we are integrating it between y equals 0 and x equals 2. Okay, so basically this piece. Now, this piece, we can rotate it in lots of different ways. We can rotate it around the y-axis. Now, in order to rotate this around the y-axis, I would say you have two options. You could either turn your head sideways and do, which method do you think it would be? I would say that that is the washer method, because you can take this outer piece and subtract the inner piece and do that all with respect to y. Make sure your equations with respect to y before you start that. You can also do the shell method, because it'd be really easy to take slices in the vertical direction here and then do cylinders. So shell method might be easier to actually integrate in the end of that problem. For part B, you could rotate it around the x-axis this way. We could rotate it around y equals 8, so we could spin it upward this direction, or we could spin it around x equals 2. So I want you to take a minute, pause the video, see if you can do a setup for each of these problems. All I want is the integral that you would use to solve. I'm going to go ahead and write them out. So if you pause the video, you can follow along now and see. So part A, if I want to rotate this around the y-axis, I said earlier we have two options. If I turn my head sideways and do it with respect to y, I'm going to solve this one real quick. Y divided by 2 equals x squared, so x equals the square root. And we're just going to keep the positive side of that. So if I do it with respect to y, then I'm doing the washer method. So I would have pi r squared minus r squared. I would be going from 0 to 8, and my outer radius would be 2, and my inner radius would be this function, square root of y over 2 dy. And that's my radius, so squared. Do I have that right? I think this would be squared minus that squared. Okay. And then instead of doing that, I also could do this shell. So that's disk. Or actually, that's washer, because I had the two different ones, right? So let's do shell. And then we could check with our calculator and see if they're equal. So for the shell method, I'm going to do 2 pi. And because I can slice it this direction, I'm doing it with respect to x. It's going to go from 0 to 2. And my height is my function, 2x squared. And my width is just x. So this one I'm sure is right. I'm wondering about my squareds on part A for some reason. All right, let's switch colors and try another one. Part B. What if I wanted to rotate this thing around the x-axis? That's probably the easiest question, because that's actually what we learned first. That would be the disk method. And all we need to do is take 2x squared and make that my radius, pi r squared dx from 0 to 2. And that's it, because we're just taking that shape and cutting it off from 0 to 2. Alrighty, part C is around the line y equals 8. So if I want to rotate it around 8, then I need to shift it up to 8 and then just spin it around. So I will take 8 minus my function, and that's going to move it up. I'm still spinning from 0 to 2, pi r squared dx. My radius is still the same height. I'm just spinning it that direction. It's 8 minus that would be the height. Okay, D. For part D, we want to spin around x equals 2. We're going to spin this direction and get like this triangle, pointy triangle shape. And this one we can it's kind of related to A. We can basically do it like A, but shift. So let's see. If I wanted to spin this way, I could just do 2 minus this in terms of y would be the square root of y over 2. And that would be this, this height. 2 minus this. This would be this height. And I could spin that around itself. So that's just squared. That's my radius. And I'm just going to square that all the way up and down from 0 to 8 pi. I forgot the pi. Pi r squared dy. There we go. Or I could do the shell method and use these heights and spin them around and make cylinders. And so these heights are 2x squared, because that's the equation of this. But my spinning would be, instead of, I don't want to spin this part, I want to spin this part. So it'd be 2 minus x, because the x needs to start from here and go this way. 2 minus x. And I want to integrate that dx from 0 to 2 because I'm doing it. And this is 2 pi rh. So I believe that would be the shell method for this problem. And that concludes 8 part C, 8.3 part C. This is the last lesson that we're doing in chapter 8. So be looking for a review and some more information about what is coming next very soon on Google Classroom.